So when you're differentiating from first principles, it's often useful to work out what f of x plus h is first before you start. So we've got 2x plus h minus x plus h all squared. So the x plus h is replacing the x. So we multiply out. Now remember, when you square a binomial, you get 3 terms. And then you can distribute the negative. Okay, now that you've got that, you can do the derivative from first principle. So watch notation is important. So f dash x is the limit as h tends to 0 of f of x plus h minus f of x over h, and you can find that on the formula sheet. So that is the limit as h tends to 0. You found f of x plus h above, and we are subtracting f of x, which is 2x minus x squared, all over h. Okay, you do have to show all this working. So now we distribute the minus 2x plus x squared, all over h. Simplify, the 2x will cancel with the negative 2x, and the minus x squared cancels with the plus 2x squared. So it's the limit as h tends to 0, and we're left with 1, 2, 3 terms. The whole point is to factorize, take out the h, 2 minus 2x minus h all over h, so that the h's cancel, and we get the limit as h tends to 0 of 2 minus 2x minus h. Don't forget to put that last one in a bracket. Now that we've gotten there, we are able to substitute 0 into h's place, and we get 2 minus 2x. Remember, the moment you do the substitution, the limit notation falls away. Okay. Over the page, we've got to find the derivative and give your answer with positive exponents. So you can only differentiate when all the variables are in the numerator. So we're not ready to differentiate yet. I also like to write it as a half x squared minus 2x to the negative 2. Now that everything is in the numerator, now we can differentiate. So dy by dx, we multiply the 2 by the half, and we get 1, and we subtract 1 from the exponent. We multiply the negative 2 by the coefficient, we get plus 4x, we take 1 away from the exponent. And we were told to give answers with positive exponents, so I need x plus 4 over x cubed to get all my marks. And then this kind of notation, you must determine the derivative of that, giving your answer with positive exponents. Again, it's not ready for differentiation, so I need to get it ready. So here I'm going to have 2x cubed over x to the 5th plus 4x over x to the 5th. Remember, the 5th root of x is the same as x to the power of 1/5. Still not ready for differentiation. When I divide powers with the same base, I keep my base and I subtract my exponents. So this is 2x, and we want 3 minus 1/3. And 3 minus 1/3 is 2 2/3, which is 7 over 3. Plus 4. Oh, sorry, that's 1/5. I thought it was 1/3. I can't even read my own handwriting. Okay, so 3 minus 1. Let's try that part again. Okay, sorry about that. So it's 2x, and it's 3 minus 1/5, which gives me 14 over 5. Okay, you can use your calculator to work that out. And then we've got plus 4x to the 4/5. Now it's ready for differentiation. So we multiply our exponent by our coefficient, and we get, now here, because you're doing the differentiation, my notation must say that equals, And 14 over 5 times 2 gives me 28 over 5 x. And then you take 1 away from the exponent. So that's 14 over 5 minus 5 over 5 gives me 9 over 5. Again, you can use your calculator for that. Plus, here we multiply our exponent by our coefficient. We get 16 over 5. X, take away 1 from the exponent, negative 1/5. We were told to give answers with positive exponents. So that x there belongs in the numerator. And here the 16 is in the numerator, the 5 is in the denominator, and the x can move to the denominator with a positive exponent. Okay. D says, given that function, calculate the coordinate of a point on f for which the tangent to f will have a gradient of 3. So this has to do something with derivative, because remember the derivative is a formula for the gradient. So let's differentiate this. It's not ready for differentiation. So we've got to say f of x. Remember, when you square binomial, you get 3 terms, distribute the negative, and simplify. Okay, now let's differentiate that. So f dashed of x is negative 2x minus 2. Now it says the coordinate of a point on f for which the tangent to f will have a gradient of 3. So let's work out minus 2x minus 2. That must have a gradient of 3. So x is negative 5 over 2. Okay, that's the x coordinate. We need the y coordinate. So we're going to take this x coordinate and substitute it back into the original. So we're working out the f of negative 5 over 2. And you can just put that into the calculator straight away. And we're going to say, can you see my calculator here? Negative. And we're going to have negative 5 over 2 plus 1 all squared plus 4. And that gives me 7 over 4. So the coordinate of the point is negative 5 over 2, 7 over 4. E, with the particle that's moving, this is a formula for displacement. And if you want velocity, the derivative of displacement is velocity. So here I'm going to say ds by dt, and differentiate that. Okay. That's also the formula for velocity. And we want the velocity of the particle after 2 seconds. So we're going to substitute 2 into t's place, and we get 0, but you need some units, meters per second, like that.